Okay, so applications of Extrema, we're just using the fact that we can have domain restrictions and that gives us endpoints to check, and then we have where the derivative is 0 or undefined, and that's where we look for maximum, say maximum profit, minimum cost, things like that. So first you read the problem and you figure out what it is you're trying to optimize. Whatever you're trying to minimize or maximize, that's what you want that thing equal to, and then that written as a function. Sketch a diagram when it makes sense to do so. Figure out what needs to be maximized or minimized. That hopefully in the beginning you've written that. Figure out the domain and then all the critical points. If the domain is closed, then you need to check the endpoints as possibilities for maximum, minimum. Okay, so we have this. So part A, we want to find an expression for the total revenue. We've got little p, which is the price, so this is a demand function. So if we want to sell X thousand CDs, then this is how we find the price that we charge. So revenue is always price times quantity. We want to find the expression for the total revenue from X thousand CDs, so we want it in terms of X. So the revenue is P times quantity, which is X times 1,000. So this equals 12,000 X minus 1,000 X squared over 8. Okay, so that's part A. So part A. There's my revenue. Okay, so B, we want to find the maximum revenue. So we need to consider domain. I need to have the quantity be positive. So note, the quantity has to be positive, so X has to be positive. Also, the price has to be positive. I'm not going to give it away free. Generally, we'd set that greater than the cost per CD, but we don't have that, so we'll just do greater than 0. So 12 minus X over 8 greater than 0. 12 greater than X over 8. Okay, so X has to be between 0 and 96. Theoretically, we could include this. We could sell none, and we could sell it for nothing because we don't know the cost right now. These will result in minimum revenue. They'll both return a 0 revenue, so it's not going to end up being the max anyway. So we could say that the domain is restricted to including between 0 and 96. Okay, so then we want to take the derivative. And that's never undefined, so we set it equal to 0. Okay, so 48 is between these two. If we plug in 0, we'll get 0. If we plug in 96, we'll get 0. That's how we found the endpoints to start with, is by setting x and p both equal to 0. So x times p will be equal to 0 at any of these points. If I plug in 48, okay, sorry. If I plug in 48, I will get not 0. So let's just... So r of 0 equals 0, r of 96 equals 0, r of 48 is 12,000 times 48 minus 125 times 48 squared. 125 times 48 is 6,000, so 6,000 times 48 equals $288,000. If you had not put the 1,000 in to start with, that would have all been fine. You would have had the 1,000 kind of existing everywhere. But then at this point, when it says find the maximum revenue, you need to spit back dollars, so it would need to be multiplied by 1,000 now. If you had at the beginning just multiplied by x. Okay, so you can, at this point, pause the video and try to do this next problem. So the first thing we want to do is write down the profit function. Then we want to maximize profit. So profit is what you have left after you pay your cost. So profit is revenue minus cost. We are given here the domain on which this makes sense. So we have 0 to 300. If you put in 0, your revenue is 0, but you have to pay this $23.40 base cost. So that's going to be hopefully our minimum profit, is when we're losing $2,340. This is minus, and that's all plus, so that's how that ended up minus. So 40x minus 5x. So here's profit. And this is in dollars, and it's X hair dryers. There are no thousands in here. So we're going to take the derivative of profit, marginal profit, and this is never undefined, so we set this equal to 0. So 175 is the number we should sell to maximize profit. So that's the answer to part B, is 75. For part C, we want to come back and plug in. So we have part A. Oh, sorry, this is part B. So then the maximum profit. So it looks like maximum profit is $722.50. Okay, and then we want marginal cost and marginal revenue, and we're going to set those two equal together. Oops. So the point is that because profit was revenue minus cost, then marginal profit was marginal revenue minus marginal cost. So if I set marginal revenue and marginal cost equal to each other, then that's the same thing as setting marginal profit equal to 0. So if marginal profit is marginal revenue minus marginal cost, which it is, then setting this equal to 0 is the same as moving that marginal revenue over and setting it equal to marginal cost. So you get that same X value is the point. And we should have plugged in 300 and 0, so I welcome you to do that. At 0, our profit would have been negative 23.40. Go ahead and plug in 300. You will get something less than this $722. But you should technically do that. Okay, this is our last one. Local club is arranging a charter flight to Hawaii. The cost is $425 for 75 passengers, but if more than 75 people sign up for the flight, and we're going to assume that more than 75 sign up, then each fare is reduced by $5 per additional person. Okay, so the price per person is going to be $425 minus $5 for everyone over 75. So we'll say X is the number of passengers. So for everybody over 75 people, we get a reduction of $5. This is only when X is bigger than 75, which we're going to assume. Also, they're not going to let you go for $0. So there's actually a restriction on here too. Let's see, this is 425 minus 5x plus 375. So once x got to be, let's see, 800 divided by 5 is 160. Once x got to be 160, that stopped doing this. They would have really stopped before, but x definitely has to be less than 160. And you could put equal signs on there, assuming they'll let you fly for free if you get that many people. Of course they won't, but anyway, the restrictions as they are listed in the problem, it would be like this. X has to be between 75 and 160. At 75, there's no reduction, so it's just 425x instead of this. And then at 160, the price becomes 0. Okay, so here is P. For between 70 and 165. Sorry, 75 and 160. So revenue, P times Q, in this case 800 minus 5x times x. So R prime is 800 minus 10x So the number of passengers that maximize the revenue is 80. And that is in this domain. So the revenue for 80 is 800 minus 5 times 80 times 80. So 32,000 they'll receive from 80. R of 75 Sorry, my brain's not functioning today. Okay, so I think this. So at 75, they make slightly less revenue, and at the 160, they would make 0 revenue because the price would be 0. So you maximize revenue at 80 passengers and the revenue at that point is 32,000.